Hello, everybody. Welcome to another Lanfrica Talks. Here today, we're joined by Dr. Hatem Haddad and Chayma Fourati. They are all from iCompass. They'll talk about African NLP and all the work they're doing at iCompass. We're happy to be joined by you, Hatem and Chayma. So Hatem Haddad is CTO and co-founder at iCompass. He received a doctorate degree in computer science and information system from University of Grenoble-Alpes, France. He was a postdoctoral fellow at VTT Technical Research Center of Finland and at Norwegian University of Science and Technology. He was also assistant professor at several universities in France, UAE, Tunisia, Turkey, and Belgium. He worked for industrial corporations like Technical Research Center of Finland, Institute of Infocom Research, Image Processing, and Applications Lab of Singapore. He was an invited researcher at Lebanese Financial School of Business in Germany and Polytechnic Institute of Coimbra in Portugal. Hatem is research interests include natural language processing, machine learning, and deep learning. Hatem is also a program chair in various global conferences and serves as a reviewer for relevant journals and conferences in artificial intelligence field. So we're grateful, we're happy to see you here, Hatem. And we have also another speaker, Chayma Fourati. Chayma is also from iCompass. She's an AI research and development engineer at iCompass. She studied software engineering at Mediterranean Institute of Technology in Tunisia. Chayma is AI trained academically and NLP trained professionally. She has published different research papers and appeared in numerous interviews locally and internationally. Her works include like text products like sentiment analysis, direct identification, head speech detection, and lots of voice products like ASR. She's currently focusing on researching on machine translation projects and for underrepresented languages. Her research interests include natural language processing, especially for low-source languages and neural networks and deep learning. So we are grateful to have you, Chayma, here. So before turning the talk to Hatem and Chayma, I have a little reminder. We have a question and answer session at the end of the presentation. So if you have questions, you can ask at the end of the presentation. But if you're shy or if you want to ask questions verbally, you can put your questions on the chat, and our speakers may answer the questions, or they will describe it. They will discuss about it at the end of the presentation. So without further ado, let's turn it over to Hatem and Chayma. So Hatem and Chayma, the space is for you now.
Thank you for the introduction. I'm always excited to talk about Africa NLP. This time we will give an overview what we had been doing at iCompass about NLP in Tunisia, but also in different African languages. So thank you for the introduction. And why I work on NLP. This is my grandmother. She is one of the smartest person that I met in my life. My grandmother never been at school at all. She doesn't know how to read or write in any language. The only language that she can talk is Tunisian. So I have a question for you. What my grandmother is doing on the left picture? Can you write on the chat? Can you guess what she is doing? I'll give you just a few seconds. So there she is counting. She's counting her money, but she created her proper way of counting because she doesn't know numbers. On the right picture, this is a special event. This was the first, let's say, democratic election that happened in Tunisia. My grandmother insisted to go to that event and to go to the election office, but she didn't do the process because she doesn't know how to read, and she doesn't know how to check which party she would like to vote for. And this is one of my major reasons why I do NLP, thinking about all the African grandmother that they never went to school, but they want to be part of the technology. They want to be part of the society. They want to have a business. They want to create a value in the society, but they don't know how to write or to read in foreign language, for instance, English or French. They know only their own language. And that's why we need to work on their languages. As Mandela said, if you talk to a man in a language he understands, that goes to his head. If you talk to him in a language that in his language, that goes to his heart. That's what Madeba told us. And I found this very great. We need to talk to people in their own language, but also create technology, services in their own languages. So the question is, are companies talking to the heart of their customers in Africa? In Africa, it's a very large population. We have something like 2,000 African dialects or languages. But unfortunately, most of the companies, they don't talk African languages. When I was doing research, I was asking big companies, why you don't work on African NLP? Their answer was, because you know English or French, so we will provide services in English or French. No need to provide services in African languages. And I found this very, very sad, because we as Africans, we need services based on our own dialects or own languages. So language is about a perception. It's a cognitive process. So when you talk to someone in a foreign language, the perception is completely different from its own language. So when we talk about big house in English, the perception is not the same in US, in England. It's not the same as in Nigeria, in Kenya, in Tunisia, in Egypt. The concept of big house is completely different. The same for bus. When I hear the word bus, for me in Tunisia, the bus is yellow. In other countries, the bus has a different color. And the word love, which is a very important word in different languages, in any language, the way we say I love you, it's different if you talk it with your own language. So I will give you a small exercise. If you write your own language or dialect, then you write the way you say I love you in your own dialect. Let's do the exercise on the chat. Just few seconds. So this is the way we say I love you in Tunisian. We can write it in Arabic character, or we can write it in Romanized or Latin character. We can do it in both ways because it's a dialect. And Tunisian, when we say, people ask me, where are you from? I say, I'm from Tunisia. Then they say, okay, you talk Arabic. It's not true. Tunisian is completely different from Arabic. They are completely different dialects. So in Tunisia, we use, it's a language or dialect based on different languages like Tamazight, French, Turkish, Italian, and other languages. Okay, and it's completely different from the modern standard Arabic, the way that we write or we read in literature or in Quran. So there is a population about 12 million people speaking Tunisian dialect. In North Africa, these dialects are very close. Algerian, Moroccan, Tunisian, they are close, but they are completely different. So to give you an example, on the left side in this table, we have an Arabic sentence The translation of it is where I can find dresses and pretty clothes. If a Tunisian hears this, a Tunisian will understand where I can find dresses and ugly clothes, because this word in red, it has a specific meaning in Arabic, which is completely the opposite in Tunisian. Same as the second sentence, I have a sister. If a Tunisian hear this Arabic sentence, he will understand I have a headache. So words can have different meanings depending on the dialect or the language. And I believe in Africa, there is dialects that they are close to each other's, but the meaning of the words are completely different. And this may cause misunderstanding and negative reactions sometimes. So the Tunisian dialect, it's not a standard language. It has no grammatical rules. It's what we call a free language. There is no rules how to write it in a lexical or semantic way. And we can have a different way to write the same word in a different ways. So I will let the floor to Chayma to introduce our first data set that we created. It's called Tunisia. Please, Chayma.
Okay, thank you. So thank you, Hatem. In fact, in order to deal with the Tunisian dialect, we created a dataset that is not in the Arabic letters, rather in Tunisi. What this Tunisi means is that we will use the Romanized alphabet in order to transcribe what we communicate. We will use like Latin characters and numbers, since they are like characters that are not included in the Latin characters, like ha, a, ha. So we are using actually numbers. So in the same word, you will find Latin characters and also numbers. In fact, in order to deal with this problem, we noticed that a large population are using this type of communication. Actually, just nowadays, the Tunisian population is more and more connected and has much more access to the internet than before. In fact, just in 2021, the population was like 11.9 million persons. And in these 11.9, we have 7.92 internet users and 8.20 million social media users just in January 2021. In fact, here, the question is, how do they express themselves on these social media platforms? And how do they communicate, create posts, or even communicate or comment on each other's posts? Surely they will not be using the MSA, neither perfect French nor perfect English. In fact, we are using the Tunisian dialect written in different forms. For example, we will have Latin characters and other ways of and Arabic ways of writing. Here we are seeing that, just like Hatem said, the Tunisian dialect features not only Arabic vocabulary, but also words and phrases from Amazigh, Italian, and even other languages. So, for example, the word aslema, it can be written in Latin, can be written in Arabic, which means in French, salut, and in English, hello, etc. And even at the end, we can find like sentences written in Latin and in Arabic. For example, confinement total, we are using hajar sahi aam in Latin and in Arabic, and also using letters and numbers for the Tunisi and Arabic letters for the Arabic ways of writing. So let's now dig deeper into the Tunisi way of writing. For example, just like I said, we are using the Romanized way of writing, and we are not using the Arabic. So for example, here's a Tunisi written sentence. الكلنا معاك وفخورين بيك notre président. This sentence means we are all with you and proud of you, our president. the sentence has 5 to 6 words. Each one of them is written in a different way. For example, the first one, الكلنا, which means we are all, is written in Tunisia only in Latin characters. معك, which means with you, is written in Latin characters and also includes the 3, which is the sound A that is not included in the Latin characters. At the end, we have notre président, which is a French word that we are using in our everyday dialect. So in order to deal with all these challenges, we have built our data set, which is the Tunisia data set, a sentiment analysis Tunisian Arabic data set that actually it includes 10K comments written in Tunisia in different ways. We have collected it, it is common crawl based corpus extracted from social media. And we have actually manually annotated it by Tunisian native speakers that understand perfectly the Tunisian dialect. It has included multi-topics like sports, politics, from influencers, etc. And it has more than 80K words and 30K unique words. It is actually balanced. It has 47% of negative comments and 53 of positive comments. And it is public and available on GitHub. However, it's actually small for deep learning activities. So we have actually done some experiments and we have results with the first version of the Tunisia dataset. Since there did not include any pre-trained models that are using this way of writing, we have experimented with MBERT, which is a multilingual BERT language model that includes different languages. And we have used different ways of experiments. We used the Word2Vec as an embedding layer. We used CNN, we used MBERT, we used BioLSTM. We have done different experiments in order to reach accuracy of 78% and F1 macro of also 78%. So since, just like I said, the first version of the dataset was not actually big enough for deep learning activities. So in order to have better results, we have enlarged it and reached 100K lines. So we have actually used the same pipeline. We collected it from crowdsourcing. We have annotated it by native Tunisian speakers. But this time we have 10 Tunisian native speakers that have done the annotation. And we have actually pre-processed it by removing links, emoji symbols, and punctuation. So also, and in this case, we have done the annotation was done by positive, negative, and neutral comments. At the end, we have 100K comments. So we have 43 of negative comments. We have 52 of positive comments and 3% of negative comments. We have also splitted it for train, validation, and test dataset for further experimenting with it. So just we have also experimented the same way we have done with the first version of the dataset. We used the MBERT, we used the CNN. We have done multi-label classification with the 3 labels, positive, negative, and neutral. And we have done a binary classification with positive and negative. And we have reached 82% of accuracy F1 macro for the binary classification, and 80% of accuracy, 80% of F1 micro, and 58% of F1 macro for the multi-label classification, because the data is not balanced in this case, and we have a small amount of neutral comments compared to the positive and the negative. So in order to have more access to the data set and people use it even more, we have published a competition on Zindi that's called the AI4D iCompass Social Media Sentiment Analysis for Tunisian Arabic. We published the Tunisia data set, and here the competition was to create the best model that would detect the label of the sentence. And actually, we were like very impressed with the number of participants. There were participants from all over the world, even from India, China, Japan, people that do not even understand the Tunisian dialect and do not even have an idea about it. So the competition was like for 6 months, and the first three teams that have won actually are not only from Tunisia. We have the first one Tunisian, the second from China, and the third from Morocco. So this was the Tunisia dataset and what we have dealt with it. Next, we will move to the Bambara dataset for the sentiment analysis. Actually, this was another dialect that we have worked with, which is the Bambara, and this project was actually accomplished by Montaga Diallo, who had his capstone internship at iCompass in 2021. So the Bambara language, you may have, I think most of the audience have done it, have an idea about it. So it's widely used in Africa. It has about 15 million people, and actually we have done the first Bambara language dataset. It's clean, it's processed, it's annotated for sentiment analysis, and can be used for machine learning and deep learning activities. It's also publicly available, anyone can use it. And it has French and Bambara included. And also it includes different topics, just like the Tunisia pipeline. We have pre-processed also the same way, and we have annotated it as positive, negative, and true, and neutral. And since we have like there are like similarities between these languages, it can be used for other languages like the Mande languages, such as Diola or Maning. So in this case, we have the first version of the dataset was like 2,404 sentences, and then we have enlarged it to reach 3K. We have neutral sentences, negative and positive. We have like 66% of positive sentences, 13% negative, and 21% neutral. So this was the first version. It's not balanced, and we have enlarged it in order to be like a little bit more balanced. So we reach 55% of positive comments, 26% of neutral, and 19% negative. So also we have experimented, and we used like machine learning and deep learning activities for experimenting with this data set. We used the first version and the second version the same, the same experiments: SVM, random forest, gradient boosting classifier, logistic regression, ridge regression for machine learning. The best results were achieved by SVM. And then we moved to the deep learning. We used the LSTM, which is long short-term memory, and BiLSTM, which is the bidirectional long short-term memory. The best result was like with the LSTM and reached 77% for the first version and 69% for the second version in terms of accuracy. Thank you, Hatem. I will let you finish this.
Thank you. Then we worked on another African language, which is the
sorry for interrupting. Before you start, there is something blocking the presentation on the right. I don't know if you could try to reshare your screen.
Like this?
Oh, it's much better now.
Much better. Okay, thank you. Okay, so the next language that we have been working on is the Faun language. This work was a collaboration with Farid, who was internship at iCompass. And the Faun language is a dialect from the Benin, but close to other dialects in the region. So there had been some work on the Faun language, but mostly for machine translation. And there is a work also by Bonaventure and Chris on this for machine translation, low resourced languages. So to create our phone dialect, we created also a sentiment analysis dataset. This dataset is composed of phone dialect and also French, the French translation of the commands. So we created a 15K dataset with different polarities. It's not a balanced dataset. There is more neutral commands than positive or negative commands. We tested the dataset with different machine learning results, going from linear regression, SVM, on a native base. We reached an accuracy of 64% with SVM and linear regression. And then we created the TuneBird language model. So the TuneBird is a pre-trained contextualized text representation for Tunisian dialect. So it's a language model. What had been done before in natural language processing, people were focusing on stemming, lemmatization, part of speech, dictionaries, lexicon. But there was very, very few work on African NLP applications in industry, and also very few in dialect. Why? Because researchers were thinking that it's very complicated to work on African languages. They don't know what is morphology of the language, the lexical level, etc. But since 2013, there was a revolution in the NLP era. It's the word-to-vec model that was created by Mikolov. And this model does not need any deep analysis of the language. So no need to go through lemmatization, stemming, part of speech. We can create any NLP application for any language without going deeper in the text analysis. That was a revolution. Then in 2019, there was a new revolution. It's the BERT language created by Google. So BERT is the pre-training of deep bidirectional transformers for language understanding. The idea here is to collect a lot of data, create a model that can understand this data without doing any deep text analysis. This was a revolution. And today, in any language, we need this language model to create applications going from sentiment analysis, named entity recognition, etc. And in 2021, we created the Tunisian language model. So to do this, we need first to collect a lot of data. So we collected something like 500K sentences, and we were sure that all these sentences are for Tunisian dialect. We did the preprocessing. It's a very basic one by removing links, emoji, punctuation, symbols, and all the non-Arabic text. So keeping only Arabic text for Tunisian. We used the same model as BERT, the same architecture as BERT. You can find the details in any BERT paper. And if you follow the steps, you can create your own language model for your dialect or your own language. I will not go deeper in this model, but you can find the details in the research paper. Once we created the language model, we applied our language model on sentiment analysis, dialect identification, and name it entity. I will go through some applications like the sentiment analysis. So we applied our language model on two public data sets about sentiment analysis. What is interesting is that our model is performing much more better than the Google model, which is the multilingual BERT. It's performing better than the word-to-vec model embedding, and performing better than a large Arabic BERT model. So the idea here is if you create your own language model for your language or your dialect, you will have better performances than using a general language model coming from Google or from Facebook. We applied also this for Tunisian dialect identification. So we did two experiments. One is Tunisian to identify Tunisian from other Arabic dialects. And the second experiment is to identify Tunisian from the Algerian dialect. Since these two dialects are very close, the experiment was to see if our model is able to identify even if the dialects are very close to each other. And the result shows that, again, our Tunisian dialect language model is performing then large but general language models. But also in the case of Algerian Tunisian, our language model has enough high performances to identify which language, which dialect is used. So we will go through a small demo to show how this work is applied in industry. And our first demo is about a multilingual chatbot. And this chatbot can identify the language and can understand the question and answer with the same language that the user is using.
We're going to present a multilingual chatbot created for a telco service provider to automate account management and purchase transactions deployed on Facebook Messenger. First of all, the chatbot sends the greeting message in French. Then it sends a horizontally scrollable carousel of services. Then it sends another message to list its functionalities. So I send a greeting message in Tunisian dialect, then another one in English with spelling errors. Next, I'll send, I want to check my internet balance. In this case, I have to enter my phone number and the code I received from the telco system. As we see, the chatbot detected the balance type, which is internet, and returned the right response. Then I'll send the same message without the balance type in Tunisian dialect using Latin letters. I'll confirm my number, and the chatbot returns buttons representing balance types. Now I'll switch the context and send the message I want to buy a package. I'll choose another phone number. Here I'm switching the language and continue in French. Then I have to enter a new validation code as well. Then I'll choose internet balance because I want to buy an internet package. Then I'll confirm the recipient number. Next, I'll choose the internet volume range and I'll choose the internet package. And next, I have to confirm my order. Then I'll cut my message into 3 different messages. The first one means listen, the second one means how, and the third one means to know my offer. So the message is listen, how to know my offer. The chatbot waits for a message containing more details so it could reply correctly. Then I'll send the word listen in French. In this message, I didn't provide enough context to the bot, so it will activate a reminder. If I don't complete my sentence, the chatbot will reach out to me after a few seconds. It will remind me of its functionalities. Also, the chatbot understands insults. And then I'll send another message, which means I want to speak with a human. I'll confirm, and the chatbot activates the handover protocol.
So this was an example of a chatbot in industry. And the main thing about this chatbot, it can detect which language is used. Is it the native language or it's French, and can answer accordingly to the user.
We're going to present a multilingual chatbot created for.
And we did also a chatbot in Nigeria. It's called Amina the Bot. It was in 2020 during the COVID pandemic, and the languages used were Igbo, Hausa, Yoruba, English, This was a collaboration with a company in Nigeria called Starfolk. And that chatbot had a great success. That was very popular at that time because it answered all kind of questions related to the COVID. But the main thing, it was using Igbo, Hausa, Uruba to simplify things for people if they are not English, if their level of English is not advanced. Then our customers asked us to work on speech. Instead of typing or writing a text message, they want to ask the message in oral way and have the answer also as a speech, not written. And that's what we were working on automatic speech recognition and on text to speech. So my first demo is about speech to text. The concept here is someone is talking and the system will transcribe what he's saying on a text.
This is the automatic speech recognition simulation, where we will automatically transcribe an audio file. Here is the first audio that we insert. Its transcription appears in few seconds.
تونس تفتخر بنظام التعليم متاعها عندها تاريخ وعندها تجربة.
We've just seen transcription of already saved files. Now we'll record an audio live and see its transcription.
عسلامة، بالله عندي مشكلة في الخط متاعي، ما حبش يكلم حتى حد، شنو نعمل؟
And here is its transcription.
عسلامة، بالله عندي مشكلة في الخط متاعي، ما حبش يكلم حتى حد، شنو نعمل؟
All transcriptions are automatically generated with our tool, files already pre-recorded or live recorded ones.
So that was the demo of speech to text. This speech to text is the Tunisian dialect used, and you can imagine the number of applications that we can use with this tool when it comes to dialects. We also did the work with the Kiswahili automatic speech recognition. We used the common voice dataset. It's a public dataset, and we reached a quite high performances with the word error rate of 5% and character error rate of 1.7. So our system is enabled to transcribe someone talking Kiswahili into a text with a very high performances. And then we have the opposite way. If we have a text written in a dialect, can we generate an audio? And this is what we will see for the Tunisian dialect, but also for French.
We have now our text-to-speech demo. We simply enter any text in the Tunisian dialect, and then our system will automatically generate a synthesized audio.
عسلامة سي سليم، كرت متاعك حذرت.
Now we enter a text written in French, and again our system will automatically generate a synthesized audio for it.
Bonjour Monsieur Salim, nous vous informons que votre carte est disponible.
So that was the text to speech.
We have now our text-to-speech demo.
Then if we have the text-to-speech and the automatic speech recognition, we can create the voice bot. So the voice bot is a chatbot, but only based on the voice. And here we will show you a small example how we can interact with the smart agent via the voice.
We're gonna present our voice bot implemented for a bank in Tunisia. It understands written and spoken Tunisian dialect by using our automatic speech recognition component and delivers the response in text and voice using our text-to-speech component. This voice bot helps entrepreneurs to complete a credit application. So first of all, we have to press on the yellow mic to start chatting with Rabeb, and Rabeb is the name of the voice bot.
عسلامة، عنا ثقة فيك، المطلب عليك والباقي علينا. التجاري بنك يخليك تعمل أول خطوة فيه مطلب الكريدي متاعك
So this is a generated voice from the machine asking a customer, explaining to the customer what will be the process to ask for a credit, and everything will be done automatically via voice. The customer will speak, but the machine will understand what the customer is saying, will transcribe it to a text, and will follow with different questions.
نبدأ بالسؤال الأول. اتفضل أعطيني اسمك ولقبك.
First, the voice bot sends 3 messages. The first one is a greeting message. The second one represents the voice bot features. And the third one contains the first question in the application. It asks for the first and last name of the applicant. Yasmin Mihiri. So I provided my first and last name.
علاش تحب تاخو كريدي؟ مثلا باش نكري حانوت.
Then it asked me why I need credit. نحب نشري سلعة. I said that I want to buy merchandise.
شو اسم الشركة متاعي؟
And then it asked me the name of my company. So this is an example of a conversation with one of our voice bots.
So that was the demo of the voice bot, and that I will go back to my grandmother. So imagine my grandmother who cannot write or read. Today she will be able to ask for a credit for a bank, do any administrative process based on her dialect and only on her voice. And recently, like 2 years ago, we heard about this.
We're gonna present our voice.
Company in Ivory Coast that is allowing the smartphones to use a local dialect, and it had a very, very large success, and it's very popular today in Ivory Coast. So all what we saw, that applications can be also done on any African dialect or language. And to close this talk, a roll-up, I would say what we need in NLP, data sets, we need data. This process of creating data is an iterative, incremental, but also collaborative process. It's iterative because creating a data set will continue. We will do it in different phases, like version 1, version 2, and each version will increment the previous one, but also collaborative because if we collaborate together in Africa, we can create large data sets. Language models are very popular today. They have very promising performances on African languages and dialects, but do we need huge data sets for this? No, we showed that for Tunisian dialect, for instance, only 500K sentences can perform better than very, very large language models provided by Google. Still a lot to do in Africa in the NLP field. There is a lot of applications that we can create, and we can do this by a synergy through collaboration in Africa. We can collaborate through universities, through startups, through researchers to do this, same as we did with the Bambara and the Fon dialect. We can imagine if we collaborate together, we can go very, very fast. Research trends in NLP today, translation is still very fashion in NLP, but 2 others two other domains are also coming: transfer learning for similar languages. So if something was done in a language, how we can transfer this to a similar language that have common characteristics. Fake news and cyberbullying detection also is very fashion today, and I encourage researchers to work on this. If you want a very nice course about NLP, I recommend the Stanford one. Is a complete one. You have videos on YouTube, but also on the website you have exercises, hands-on exercises, labs that are with their solutions. So that was about our presentation. Don't hesitate to contact us if you need more information. All these data sets are public. If you want to access them, and you cannot find them on internet, please to contact us, and we are very open to collaborate in any African language or any application. Thank you.
Thank you, Hatem. Thank you, Chayma, for the wonderful talk. It's really impressive. I like it. Starting from your inspiration, and then what he did on Tunisia, and not limited to Tunisian languages, but also to languages in other parts of Africa. That's really, really impressive. I like your work. So I think let me ask my question. My question is about you're talking about data set collection. You collect data sets by yourself. I know how hard is collecting data sets. So maybe I think it will be good if you explain about how you annotate data sets, like you are using manual annotation, or you are also using other techniques. Like I wish if you can give more explanation on that. And also, I have a question on Trumbert. So, as I say, you train the model from scratch. You don't pre-train the BERT model. So, I have a question. I think like I was thinking like fine-tuning was good, but when I see here, instead of fine-tuning the BERT model, you just use the structure and train it from scratch, and it gives you a better accuracy than BERT. So you advise me to train a model from scratch or to fine-tune it? So I have some confusion there, and I want you to clear for me. And that's all, I think. So yeah.
For the first question, how we collect data sets for underrepresented language, it's very hard because there is not enough data. The main challenge is to find where is the data. So we collect from any place that we have access and it's public. It might be YouTube, it might be social media, but also we didn't hesitate to go and find data in radio, local radios, TV, ask them to have the data. So any place is good to collect the data, because if you work in an underrepresented or low-resourced one, you will find a hard time at the beginning to find the data. So don't hesitate. We went to writers, we collected books, any place. Then the annotation is done manually. We created a small interface that helped us to annotate. We did this at home, in-house, because there was no data available at that time for Tunisian, but also for Fon and Bambara language, there was no annotated data. We did it by ourselves. It takes time to do it, but we need to do it. There is no other way than this to create the first one. Once we created the first one, other people will create an incrementation of that data set, and it will get bigger, 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 until we get enough big one to apply deep learning. When it comes to the second question, we did. So Google is providing a language model. It's a multilingual language model, including I don't know, more than 100 languages. We created one from scratch for the Tunisian one. And not only for Tunisian, but also we tested on other languages. And we find out that not only us, but many researchers in NLP, if you create a language model specific to a dialect or a language, you will get better performances. So, for instance, for Igbo, we need a language model for Igbo. For Hausa, we need a language model for Hausa. For Bambara, we need a language model for Bambara. It's a lot of work, yes, but the good news that we don't need a lot of data to create a language model. That we showed that even with a small 500K sentence, we can have a language model performing better than Google. So why not to do it for each African language if it's possible? Yeah. So my advice, yes, if you create from scratch your language model, you will get better performances, whatever the application.
Does that depends on the amount of data set I have? Like, I think if I just have some thousands of data sets and fine tune it, maybe it will be better to fine-tuning can give me a better result than doing it from scratch. So do you think it depends on the amount of data set I have?
Yeah, sure.
So that's good. Can we get the models you trained on Hugging Face or any different platforms?
Yeah, all our models are public. You can find them at the end of the presentation. We put all the links, but if you do a small research on Google, you will find all the data sets and the model. The Tune-BERT model is also available.
Okay, that's great. So we have a question from Ifoma. Ifoma, you can ask the question.
Oh, can you hear me?
Yeah, you can hear you. You can continue.
Good afternoon, everyone. I was also particularly interested when he said that he trained the model. I wanted to know how this works, probably in a multilingual perspective. Like the demo you showed, you were using different languages in the chatbots. Like if we are to have a kind of multilingual chatbot, and we've built the model separately for each language, how would that work? So are we going to like combine all the language models and have it detect or something?
The way we are doing this, that is the first level of the chatbot is detecting the language. So you have the question, then the chatbot will understand which language is it and ping it to the specific language model.
I have another question.
Yes, please.
Can you hear me? Okay, so my own is not really concerning this chatbot. It's about your work on dialect identification, and I have a very strong interest in that. Okay, how did you train your model, and did you treat the dialect as languages, or you treat them as dialects of a single language? So if you do that, how did you do ASR, or you just made it textual based research? And if you do spoken data, how were you able to identify, dialects are only, well, in my own opinion, most of the time they are accentuated, which I wish to pursue for my PhD, where I want to see a way to do a type of deep learning, deep phonology or phonetics, where you just put all the data sets in the model and the model identify the language, the dialects, not the language now. So since a word like you showed in Tunisia, which shows that the standard Arabic is quite different from the Tunisia Arabic, which means that they are two different languages. But in a way, we will have Tunisia dialects of Arabic, where the one spoken in northern Tunisia is different from the one spoken in southern Tunisia or in central Tunisia. I'm just trying to guess. So that way we may not have lexical difference, but we have accentual differences. So the way this word is pronounced is just pronounced in another way, in a slight different way from this region, which is trying to mark the dialectal differences. So how did you deal with these integrities in your work?
Okay, thank you for the question. It's very interesting. Yes, indeed, what we did is dialect identification on the text level. We analyze dialect as any language. So for me, as a technical part, dialect or language, they are the same. I'm not talking about linguistic level. Maybe some linguistic specialists, they have a different opinion, but for natural language processing, a dialect or a language, they are the same. You process it the same way. So for text, pardon?
Okay, sorry to cut you short. I love what you said, how that for NLP, you are only interested in processing the language as whether it is dialect or not, it's just language. I am a linguist, so I had to just pick this as an interest. So it's an interesting thing, and I've been observing over time, which you made a very right point. But I'm really concerned because textually, if you have dialect, you might not get the difference you are looking for. As I was saying, dialect, okay, for example, in Yoruba has more than 20 dialects. And within that dialect, of course, we have textual differences. And when you are saying textual differences, now you're talking about whether the words are different. Then you are basically looking at what words are different, okay, in one dialect to another. Which will be, sorry, I think I lost the call there. Hello?
Yeah, we missed it. Yeah, you're clear now. You can talk now. We missed you for some time.
Okay, so I'm so sorry to stretch you further. I'm just trying to make some clarification. Okay, so if we try to look at it from the textual level, then we have just minimal differences. But if we look at it on the phonetic level, we know different pronunciations and different words. So if we process dialect the same way we process languages, we might fall into troubles trying to identify dialects of the same language. I don't know whether you get my point. So, well, I don't want to take it further, but that's just what I want to comment on when you said something concerning but you made the right choice, the right point, as I've heard people say the same thing over time.
I agree with you that there's still a lot of work, as I mentioned at the end. Still a lot of work on African languages, especially on the speech level, which is a bit more complicated than the textual level. And this is an open domain where mostly no one had been working on it. And we had today a great opportunity to have this technology of deep learning, speech recognition, speech analysis to work on this.
Thank you, Samuel, for the question. So, and we have also another question from Ifoma. Ifoma, you can unmute yourself and ask the question.
Yeah, sorry, I'm coming again. It's based on, for me, I don't know the main difference between dialect and language, but I was really concerned about the identification. So you see, like one word could mean different things in different languages. Like you identified for pretty, it means something else in Tunisian language and something else in Arabic. So when you have a situation like that, how does the model reconcile? For example, you are doing language identification. How does the model know that this Tunisian and this no Arabic, especially if you don't have surrounding text, like you don't have text around that can be able to guide it on what language a question is being asked in?
Okay, thank you. Chayma is I've been working on this for a long time. Chayma, do you want to give some clarification on this?
Yes, but I actually have lost the sound at the end of the sentence.
Okay,
I'm sorry.
it's about dialect identification, how to identify between different dialects, especially for instance, Algerian and Tunisian, where they are very close dialects, how we do the identification.
Yes. So we actually have dealt with this problem for different dialects. We have collected for each language like a data set, and we have annotated it as, for example, the Tunisian dialect. You have the label Tunisian, and then we collect like for example, Algerian. We will collect Algerian sentences from different sources, and we will give it the label Algerian. And then we will pre-process it. We will have the same pipeline as we did, for example, for dense sentiment analysis. And then we will create a pipeline. We will create models. We will train the model on these two on this data set that we have created with these two dialects. And then we will experiment with, for example, we have done machine learning, deep learning, and then we used the language models until we reach the best performances for detecting for the languages that we need. And we can have more than like binary classification, for example, Tunisian, Algerian. We can use like multi-label classification exercise. We can include different languages, and then we train the model so that it understands the specificities of each language, and then detect whether it is, for example, Tunisian or Algerian. I hope that answers your question.
Yeah, so thank you, Ifoma, for the question. So if we have more questions, we can continue. Ifoma, you have a question? Okay. So if we don't have more questions, I think we can start from here. I see my Samuel and Ifoma, people from Nigeria, they're interested on your work on dialect. I see, that's interesting to see. I hope I will see my language also in one of your works in future. So that's interesting. I like your talk in general. It's very impressive. What you are doing at iCompass is impressive. I want to keep up on this. I want to see many works on other languages on Africa. So thank you for the wonderful talk. Thank you. We are grateful to have you here. Thank you, everybody here, for being an audience. Thank you, Samuel and Ifoma, for being an awesome audience. So I hope I will see you next time on another talk. Okay, thank you, guys, and we're going to quiet here. So thank you, guys. See you on another Lanfrica talks. Bye.